Factoring it, you leave it as the factors. Factoring it, we leave it as the factors. But when we say solve it, we set those factors equal to 0 and solve each different linear equation. Don't make the mistake of solving it when it says factor. All right, picking up where we left off, we were looking at this Pythagorean theorem. Whenever you have a right triangle and you're given the lengths of all sides of the right triangle, we say one of the sides is a leg and the other side's a leg, but this side is called the hypotenuse. The longest side of any right triangle is called your hypotenuse. And the theorem that relates the lengths of all of those is the Pythagorean theorem, which says in a right triangle, the square, meaning square each length, the square of the length hypotenuse, equals the sum of the squares of the lengths of the legs. So if this leg is A and this leg is B, we square those and add them up. A squared plus B squared equals C squared. So anytime we have these right triangles, we label our 90-degree angle. And it says the legs are labeled x, x plus 4, and the hypotenuse is 20. Now the lengths of the legs, you square those. So that's an x squared and an x plus 4 squared. And that equals the hypotenuse squared. And in this case, the hypotenuse is 20. So be careful. Remember, when you square a binomial, you rewrite it twice. And we get x squared plus 4x is 8x. And then plus 16, giving us x squared plus 8x plus 16. So we got the first x squared. Then we have the x plus 4 squared, which is 8x, x squared plus 8x plus 16. And 20 times 20 is 400. Okay, so there's our quadratic equation that we have to solve. The left side is 2x squared plus 8x, and then we'll subtract 400 from both sides. And that gives us minus 384. Yeah, that's kind of a big number, but at least everything's divisible by 2. Factoring out the 2, we get x squared plus 4x minus 192. All right, so these numbers are a little bit harder to find. We have negative 192 that adds to 4. And 9, 10, 11, 12, that's divisible by 3. And that's going to give us 6 times 3 is 18, 64. Or I think it was 16 and negative 12. Yeah, I think we did this one last night. But that's okay, we'll do it again. 2 times x plus 16 and x minus 12. Okay, so remember the dividing, the 2 there, you can divide it out. It doesn't need to be there. And then you have x plus 16 times x minus 12 equals 0. Setting those equal to 0, we get negative 16 and 12. But remember, lengths in geometry can't be negative. So we cross that one out and we say x equals 12. X plus 4 is 16. And so our legs are 12 and 16. Okay, please try that one. You've got your leg x, which you're going to square. You've got your leg x minus 3, which you're going to square. And that's equal to the square of the hypotenuse. So I'll give you a little bit of time to work on that. All right, so one of the legs is x. The other length or other leg is x minus 3 equals 15 squared. This gives you x squared. When you square a binomial, you FOIL it out. X squared minus 6x minus 6x minus 3x minus 3x is minus 6x. And negative 3 times negative 3 is positive 9. 15 squared is 225. X squared plus x squared is 2x squared minus 6x. 9 minus 225 is negative 216. Now everything is divisible by 2. X squared minus 3x minus 108. To get negative 108 and a negative 3. We've got 9 and negative 12. So we get x plus 9 and x minus 12. Divide both sides by 2. So the first one's negative 9 and the second one's 12. Negative lengths are extraneous. They don't mean anything. And so if one of the legs is 12, the other one is 12 minus 3, which is 9. So our legs are 9 and 12. All right, example 4. One leg of a right triangle is 17 inches longer than the other leg. The hypotenuse is 25. Now we've got some big numbers. Find the lengths of the two legs. So we sum the squares of the legs. X plus 17 squared plus x squared is 25 squared. If we square x plus 17, you're going to get x squared plus 17x plus 17x, which is 34x plus 17 times 17. That's plus 289. And 25 times 25 is 625. All right, so you subtract 625 from both sides. $625 minus 289 is negative 336. I forgot to add the x squared in there. And so that gives us 2x squared plus 34x minus 336. As we did before, we factor out the 2, x squared plus 17x minus 168 equals 0. Well, that's not too bad. Negative 168 to get 17. 4 goes into 168. 42 times. 6 goes in there 28 times. 7 goes in there 24 times. All right, so our factors are x minus 7 and x plus 24. Remember, the 2 is irrelevant, and so it says x minus 7 and x plus 24 equals 0. So we get 7 and negative 24. But negative 24 is irrelevant, or extraneous, we like to say. So x equals 7 is one of our legs, and the other one is x plus 17. 7 plus 17 is 24. So our legs are 7 and 24. All right, the next one's kind of interesting. When you have a rectangular television and they say a 32-inch or a 10-inch television, that's always the length of the diagonal. So obviously this is a really small TV. Maybe we call that an iPad mini or something like that, to have a 10-inch diagonal screen. And it says it's 2 inches wider than it is tall. So what you guys have to do is take a right triangle whose sides are x and x plus 2 and find the dimensions of the TV screen. This would be something you would do to make sure it fits in a corner where you want to wall mount your TV. So I will give you a little bit of time to try to figure that out. Okay, so yes, we'll determine that this is not such a large TV. We have one leg is x, we square that. The other one is x plus 2, and we square that. And that's equal to the square of the hypotenuse. Remember, when you FOIL out a binomial, x times x is x squared, x times 2 is 2x, plus another 2x is 4x, plus 4 equals 100. X squared plus x squared is 2x squared, plus 4x. When we subtract 100 from both sides, we get negative 96. So we factor out a 2, giving us x squared plus 2x minus 48. Go ahead and divide out that 2. And when we divide out that 2, we get x squared plus 2x minus 48 equals 0. So that one factors as x plus 8 and x minus 6. Setting those factors equal to 0, we get x equals negative 8, or x is equal to 6. And so this is a case where negative 8 doesn't work, but x equals 6. And then 2 more than x is 8. So this is a 6-inch by 8-inch TV, about the size of an iPad. But if I made the problem any bigger, like a regular TV, the numbers would be so hard for us to solve. So just for the sake of an exercise, gave you a small TV. All right, practice 4 is an important one. This one is very similar to the problem that we did in example 2. You have a rectangular room. And its length is 5 feet less than twice the width. So one of these is going to be W, and the other one is 5 feet less than twice that width. But now we're telling you the area is 63 square feet. So you take the length and multiply it by the width, and that gives you 63. The length is 2W minus 5, and the width is W. So you multiply those two together, set it equal to 63, and then factor it and solve. So I'll give you a little bit of time to work on that. The length is 2W minus 5. The width is W, and that's equal to 63. So we distribute that and get 2W squared minus 5W equals 63. Okay, so yeah, these numbers are kind of big, so let's see what happens. The AC method, we have 2 times negative 63, which is negative 126, that adds to negative 5. For lack of a better answer, I know to start with 3 and 42. 4, 5, 6, and 21. That's negative 15. 7 and negative 18 is negative 11. 9 and 14 is negative 5. So we place those numbers in there as 2W squared plus 9W minus 14W minus 63 equals 0. We factor out a W from those first two, W and 2W plus 9. And then we factor out a negative 7 from those two, which leaves us with 2W plus 9. So we factor out the 2W plus 9, and that leaves us with W minus 7. All right, so we get W equals 7, or that one you'd subtract 9 and divide by 2. And remember, this one is extraneous. So we cross it out. And we say that the width is 7. If the area is 63, then the length would have to be 9 to get 63, or you plug it into 2W minus 5, which is 2 times 7, 14, minus 5 is 9. So we get W equals 7 and L equals 9. Okay, so again, remember, I love to ask problems like this on the exam about the area of a rectangle. Okay, so that concludes 6.7 and the material that you'll be expected to know for your next test. Now we go into chapter 7 and section 7.1, which is titled Rational Expressions. The word rational here is different than the word rational that we use in the English language. Rational here implies that we're going to have some kind of ratio, and ratio means division. But a rational expression is more than just a fraction. It's going to have a variable in the numerator and variables in the denominator. That's what a rational expression looks like. And so some of the skills we're going to need for this are, well, being able to solve quadratic equations, like this one. We do this one by the AC method. 3 times negative 2 is negative 6. That adds to negative 5. That's negative 6 and 1. And so we put those back in there. We factor out the 3x, and that leaves us with x minus 2 and another x minus 2. So we factor that x minus 2 off to the right-hand side, and we're left with 3x plus 1. So if 3x plus 1 equals 0, we subtract 1 from both sides and divide by 3. But if x minus 2 equals 0, we add 2 and get x equal to 2. So there's no throwing out any negative numbers here now because it's not an application problem. Now the next idea that goes along with this stuff is if you pick a certain value when you plug it in and you end up with 0 in the denominator, taking something and dividing it into 0 pieces doesn't make any sense. Or taking $5 and dividing it by 5 people doesn't make any sense. So we say this is undefined. And we've seen this before when we saw a vertical line that was all rise and run was 0. So we do rise over run, and we would get 0 on the bottom and any number on the top, and we said this was an undefined slope. So we're worried about those kinds of things. When we have a rational expression and you have a denominator where the denominator is q, we want to make sure that we don't divide by 0. So we say the rational expression is a quotient or division of 2 polynomials. That is, we write it in the form p over q, but we want to make sure that p and q are polynomials and q is not equal to 0. So when we see things like x plus 2 over 3x minus 5, it's a rational expression. The fact that there's an x in the denominator tells us that we wouldn't want to have 5/3 for x because that'll make us get 0. Whereas if we have a squared minus 3a minus 8 over a plus 7, it's only the denominator that you don't want to be 0. So you would assume that a isn't equal to negative 7. The numerator can be anything. And the last one, you have x plus y in the denominator. You'd want to make sure that x never equals negative y, because then you'd have 0 in the denominator. So we're going to work with these rational expressions, or fractions as we call them sometimes, and simplify them. But first, before we simplify them, we'll just evaluate them or find the value. Now, there's really no reason to do both of these, so I'm just going to do for x equal to negative 5. If x equals negative 5, then I've got 3 over 5 times negative 5 plus 1. As long as we don't get 0 in the denominator, then these numbers are okay. That's 3 over negative 25 plus 1, or 3 over negative 25 plus 1 is negative 24. We simplify that fraction. And 3 goes into 24 8 times. We get negative 1 over 8. So if we plugged in a different value for x, we would get a different number, but for -5, that value is -1/8. Whereas if you plug -5 into the next expression, then you have -5 squared plus 6 times -5 plus 9. And that's -5 plus 1. -5 squared is 25. 6 times -5 is -30 plus 9 over -5 plus 1. All right, so we didn't get 0 in the denominator for this one either. So 25 minus 30 is -5. -5 plus 9 is 4 over -4 gives us -1. It's pretty easy to see that as long as you don't plug in an x equal to -1, then you'll be okay. You'll get an output. But once you plug in -1, it's undefined. So that's precisely what we talk about now. What value will make the expression undefined? Because we know that a rational expression is undefined for those values of the variable or variables that make the denominator 0, we find those values for which a rational expression is undefined by saying, when does my denominator equal to 0? And we solve the resulting equation. We see that we would divide by 0 if x is equal to 5/3. But if my denominator is 3x squared minus 5x plus 2, knowing when it is going to be 0 amounts to solving this equation by setting it equal to 0. Quadratic equations, we can solve this by the AC method. 3 times -2 is -6. Product of two numbers, it's -6. That adds to -5. -6 and 1 are those numbers that do it. So we have 3x squared minus 6x plus x minus 2. We factor out that x, 3x, and we get x minus 2 plus 1 times x minus 2. We factor off the x minus 2 to the right-hand side, and we're left with 3x plus 1. The two numbers that make the expression undefined are x equal 2 and x equal to -1/3. But again, notice it doesn't matter what the numerator is. What happened to x? Well, Big Ellie, I'm not really sure what you're asking me there. What happened to x? We wanted to know the values for x that make it undefined. So we say that x equals -1/3 and x equal 2 make it undefined. What happened to the x plus 2? Good question. All right. It does not matter what the numerator is to make it undefined. It's irrelevant. It's just the denominator, because 1 divided by 0 is undefined. I can have anything on the top, but if 0 is on the bottom, it's undefined. So I don't care what the value of x plus 2 is. Only the denominator when we talk about undefined. Okay, so what value makes 3 over x plus 7 undefined? What value for x would make me divide by 0? Good. X plus 7. If that ever equals 0, then you get x equals -7. What about the value for n that makes 3n plus 5 equal to 0? Remember, if you want to know when 3n plus 5 equal to 0, you set it equal to 0, and then you subtract 5 from both sides. And then you divide by 3, and that says negative 5/3. Now, everyone has a hard time looking at what makes x squared plus 2x minus 3 equal to 0. So we actually set it equal to 0, factor it as a product of two binomials, and then state the values that make each factor equal to 0. Tell me what you get on that. That's because you have x minus 3 and x plus 1 for your factors. No, we don't. We have x plus 3 and x minus 1 for our factors. So we get negative 3 and x equal to 1 for the two values that make our expression undefined. Now, what that really means is that if you were to graph something like 3 over x plus 7, it just means you won't get a graph for x equal to negative 7. Where it's undefined, it means you don't get a point for that particular x value. Now, simplifying rational expressions amounts to factoring your numerator and denominator and then dividing out. We like to say cancel. 85 has a factor of 17, and so does 68. That's common. So we divide it out by canceling it, and we're left with 5/4. So this is where all the factoring tools or factoring techniques take over. To simplify a rational expression, we factor it numerator and denominator and cancel the common factor. So you have to always completely factor the numerator and denominator and then divide them out. So as long as you are making sure to factor first and then divide out common factors, this is pretty straightforward. My numerator has a GCF of 3n, and that will leave me with n plus 4. My denominator is 6n. So what's like each other on the top and the bottom are these n's right here. And then the 3 goes into 6 2 times, leaving the 3 gone on the top. So the only thing left over on the bottom is a 2, and the top is an n plus 4. Letter B, you factor out a 2 from the numerator. And in the denominator, I taught you several times that when it's a leading term of a negative, go ahead and take out the negative leading coefficient, negative 4. And that'll leave us with a z plus 2. Completely factoring everything, the numerator is 2 times z plus 2, z plus 1, divided by negative 4 times z plus 2. We see that the z plus 2's divide out. The 2 goes into 4 twice. We get negative Z plus 1 over 2. Okay, so notice how I'm making sure to factor first. I'm not coming along and saying there's a 4 in the top and a 4 in the bottom. That doesn't work, and that's what the work smart says there. You can't cross these things out. What you have to do is first factor and then cross out. So don't get caught up in trying to cross out before you factor. All right, the last one. The numerator is a squared plus 3a minus 28, which factors as a 7 and a 4, positive 7 and negative 4. Let's see, the denominator, the product of two numbers, it's negative 56 that adds to negative 1, negative 8, and 7. That's a 2a squared minus 8a plus 7a minus 28. So that's a 2a that can come out, which leaves a minus 4, and a 7 that can come out, which leaves a minus 4. So that gives us a 2a plus 7 and an a minus 4. Cross out the a minus 4s, and we're left with a plus 7, all divided by 2a plus 7. Okay, so please tell me what you get for practice 2a. From the numerator, we pull out a 4, and we're left with x minus 5. From the denominator, we pull off a 6x, and we're left with x minus 5. So we cross out the x minus 5s, and then the 4 and the 6 both have a common factor of 2. 2 goes into 4 twice, 2 goes in 6 3. So we get 2 over 3x. Okay, now try practice 2b. Okay, so there's two ways to approach this one. One is the direct way. The numerator is x minus 2 and x plus 2. And the denominator, well, you can use the AC method on that to factor it. Negative 28 to get negative 3, and you'd use negative 6 and 4. So you do 2x squared minus 7x plus 4x minus 14. Factoring out the x leaves us with 2x minus 7. Factoring out the 2 leaves us with 2x minus 7. Now we see we have an x plus 2 and a 2x minus 7. So we cross out what they have in common. And we get x minus 2 over 2x minus 7. Now the other way I like to show you guys is this. The only way this will simplify is if the denominator has one of these two as a factor. If it doesn't, then this will be the final answer. And so we just say, well, is there any way that an x and a 2 could be a factor of this 2x squared minus 3x minus 14? Well, if that's the case, to get 2x squared, that's going to have to be a 2x. To get negative 14, that's going to have to be a 7. Well, 1's going to have to be a negative because it's negative 14, but we want to get negative 3. So if I make this one the negative 7x and this is the 4x, then that'll give me the negative 3x. Now, negative 7x plus 4x is negative 3x, so it worked. And so the x plus 2's cancel out, and we get x minus 2 over 2x minus 7. So I'll try to show you a little bit more that trick as time goes on. But I like that because using the AC method sometimes can take a little bit of time. And guessing and checking at answers can take less time. But you're always welcome to go back and use the AC method. All right, I think that's all I'm going to cover for tonight. Pretty close to the 10:15 mark that I like to stop at. And so we'll finish the rest of this up on Wednesday.